Hello, everybody. Welcome to the Critical Canadian Building Science webinar series by Building Knowledge Canada. Welcome back on another Thursday afternoon. I think we're in our, what is this, third year now? Anyways, we'll let everyone sort of come online and get settled into their respective Zoom rooms. I was thinking this having a little bit of a building science geek chat with some of our team recently. For those of you out there that are sort of spend your waking hours thinking about building science, we are in the design day weeks of the year, right? All of our design day temperatures are the last 2 weeks of January. Who knew? Maybe we should add another long weekend to celebrate design day. I don't know. We'll see. All right, so welcome everybody to the Critical Canadian Building Science webinar series. Today, our topic is hybrid heating for homes. And hybrid has sort of a broad context. I think there's still some discussion out there as to hybrid. Does that mean dual fuel? Does it mean moving energy by both air and by water or another medium? But oftentimes it's a little bit of both, but we've got some experts here today. They're going to help us with that. As we get started, we actually wouldn't be able to do a lot of these webinars without the help of our sponsor for this session today, which is Enbridge. We're going to have Brandon come on here in just a minute after I go through the agenda. We're going to do some introductions. We'll bring Brandon on first. We'll do some housekeeping. We're going to get you ready, all set up with protocols for attending these webinars. And then we're going to have our session experts give a presentation, both Steve Myers and Jason today. And then we're going to leave a little time for some Q&A as well. And as usual, if there's questions that come in that we don't get to, we usually try to send those out afterwards. And please remember, take 5 seconds at the end of today and just do the review if you can, the surveys that comes out. As we move through the slides today too, folks, keep your eye. If you have questions, make sure you put them in the chat, but keep your eye over or put them in the Q&A. In the chat, keep an eye on helpful links that are shown. So without further ado, Brandon, welcome on.
Thanks, Andy. Happy to be here today and be a part of this. Good afternoon, everyone. I'm Brandon Lighthart, and my role with Enbridge is focused on cultivating and managing relationships with HVAC industry professionals in Ontario. I'm passionate about driving sustainability, reliability, and affordability in the residential HVAC market. And my emphasis will be on new construction accounts. However, Enbridge wants to ensure we're meeting the unique needs of all of our HVAC partners with education and tailored natural gas solutions. You can take note of my contact info here or ask in the meeting chat if you have any questions. I'll just take a minute to do the traditional acknowledgement. We'd like to start today's session by acknowledging that the land on which we gather is the traditional and historical lands of the original people of Turtle Island, who have been the caretakers of these lands since time immemorial. Today, this gathering place is home to many First Nation, Métis, and Inuit peoples. Our acknowledgement of this reminds us that our great standard of living is directly related to the resources of and relationship to Indigenous people, and we have a responsibility to honor that.
Thanks, Brandon. Thanks for that. There you go.
I'll briefly mention our energy conservation programs for residential new construction, which are incentivizing builders to build beyond code. And these are strategic initiatives designed to remove barriers and actively promote the adoption of energy efficient technologies and practices. Next. So the goal of our Energy Star for New Homes initiative is boosting the market penetration of Energy Star or equivalent homes in areas that have had historically low adoption. You can contact your regional Enbridge builder rep to confirm which municipalities qualify for this offer. Homes must be built in an eligible municipality within the Enbridge gas service area. And Energy Star certified homes are 15 to 20% more energy efficient on average than a home built to code. And builders do have flexibility with their direction to achieve these standards. Hybrid heating is a great option that is commonly used. However, a variety of heating systems can be used. Eligible builders can claim incentives of $1,650 per home for up to 50 homes per year. One point to note is that this program is scheduled to wind down by the end of the year, so it will not be continued into 2026. But the funds for 2025 have been reserved for participants that wish to enter.
Nice. Yeah, thanks, Brandon. I know we do actually have a number of builders on today that actually do participate in this. So just a reminder, please reach out to Brandon on this. And if you are already working with someone at Building Knowledge Canada, we can help connect with Brandon as well too. So
for sure. Thank you. So yeah, now we got Net Zero Energy Ready. And this is a great program for builders which have not previously labeled net zero or net zero ready homes because of the expert knowledge provided through the workshops and trainings, which do include trainings for your trade and sales teams as well. This program is designed to guide builders and make that first step of the process much easier. The discovery home that you build must be located in an Enbridge gas service area. And many builders and HVAC professionals are using hybrid natural gas heating systems, but similar to the Energy Star new homes, a variety of HVAC options can be used here. Your project must be in the pre-design stage when you apply. That's an important thing to remember. And you must be a builder member of CHBA by virtue of being a builder member of a local Ontario HVA.
cool. And again, I'll just real quick, I think, Brandon, you folks have some spaces still open up to this, right? And it is a limited sort of first come, first serve. Is that right?
Yep, we do. We definitely have spots open for it.
Okay, very good. Yeah, very neat program. A lot of builders end up trying out some pretty cool technologies during this. And you can do it on a show home, you can do it on a spec, you can do it for a client, all sorts of cool stuff. Okay, yeah. Thank you, Brandon, very much. Good to have you on.
Thank you.
The housekeeping rules of engagement for today. So quick reminder, if you have a question about the content and for our experts today, please put it into the Q&A. The Q&A allows us to track the questions, to audit them, and to record them, actually, so that they can be printed out in transcripts later on. If you have questions about, hey, my Zoom's not working, or you need to contact Stacy, who's on the back end helping us manage this, please put that over into the chat. Anyways, we're very glad to have you. As good Canadians, again, be considerate, thoughtful, please be respectful in the conversation and the chat. We're all at different stages in our journey along this line to efficiency and sustainability and, addressing things like carbon and comfort. The webinar is recorded today, so it's going to be available immediately after the presentation. You'll receive that. And then all of the Critical Canadian Building Science series plus other Enbridge supported videos are actually on a YouTube channel that you can watch with your team or listen to as sort of a podcast. Please complete the Survey Monkeys after the session. It really helps us determine content. Links, please note, again, follow in the chat. There will be some helpful links to hop in there. Closed captioning is enabled for you. And again, we've got Stacy manning the back into this, Stacy Cooper. So if you have issues, just put that over into the chat. So I'm going to bring on, we've got Steve Myers today. Steve's got 20 plus years in the mechanical industry, working with a company called Air Solutions, who works with a variety of products, a variety of technologies, and who is working with all sorts of clients all across Canada. We also have Jason Rende, one of our own Building Knowledge Canada team members. Jason is actually one of our senior designers Jason's been doing mechanical design for over 13 years, and you'll get to see he's got a bit of a case study today that he's done on a design using a very simple hybrid heating system that we often see today. You'll sort of see how that's done and what it entails. So I have myself as your host, and I'll just sort of correlate the questions in the Q&A. I might poke some fun at Steve and ask him some colorful questions once in a while, but we're really glad to have him with us. Before we get started, you folks know the drill. We're going to run some polls. So the sooner we get through the polls, the sooner we get to Steve. So Stacy, let's find out where these folks are located today. We've got sort of let the horses out of the gate and see what happens here. Got some folks from British Columbia, got Saskatchewan, some Manitoba, Alberta, got some folks from Ontario, Atlantic provinces, got some folks in the territories too. Even a few folks from the US, imagine that. So regards to our friends south of the border and abroad. Well, thank you. Yeah, that's good. So yeah, we've got folks from right across the board. Stacy, maybe we can run the other poll. One more thing to ask you is, what do you do on a day-to-day basis? Who are you? And as usual, if any of these sections don't capture what you do, just throw that over in the chat. It's always good to know. Of course, there's a lot of familiar names on here too, Steve? You look in. Yeah. We know what they do. Maybe we'll be surprised with some of these folks. So we've got some builders, renovators, engineers, architects, mechanical contractors, construction staff, HVAC designers, consultants, building inspectors, and others. So I imagine over in the chat, we're going to have a few shortly as to what they do. All right. A good portion of them are builder, renovators, and developers. Excellent. Okay. Well, thank you folks very much. I see we've got some folks that work on climate policy work as well too. Good to have you. Very good to have you. Okay, Steve. Well, I guess the next step is let's get started. So I'm going to stop sharing my screen and welcome aboard, and feel free to add a little bit more and elaborate on your background too.
Sounds good, Andy. Thank you very much. You can hear me okay?
We can hear you good.
Fantastic. I'm going to share my screen here. See that okay?
We can. Yep. It's there it is, and it's in presentation mode. Look at that.
All right, perfect. Thank you very much for having me, and I really appreciate the opportunity to help educate the community that attends these webinars. Myself, thank you for introducing me. Like you said, 20 plus years in the HVAC and water heating side of the industry. My role with Air Solutions is builder development. So I'm working with builders, HVAC designers, new construction contractors to help them develop new solutions to maybe some of the problems that they're having in their homes, and coming up with solutions. So my company, Air Solutions, just to introduce us a little bit, Air Solutions, the manufacturer's representative in the HVAC building industry. So what that means is that we act as a sales team for manufacturers such as Navien, Fujitsu, Broan, Vanny, probably products that a lot of people on here are already using. We have 2 offices in Ontario. We have an office in Guelph and we have an office in Kingston, and we've been in business for about 38 years. We're a very forward-thinking company. We only represent manufacturers that align with our core values, which is efficiency and reliability of our equipment. And then we primarily work in Ontario, but we represent products in Manitoba, Saskatchewan, and Alberta as well. So just to go over the agenda, my agenda. Sorry, Andy, I know you had your own agenda there, but
That's good.
Everybody, but first things first, we must cover the basics so that this gives us a basis of information I will be providing later in the presentation. So we're going to go over, heat pumps, standard HVAC systems, that sort of thing, just so you have that understanding. And we're going to focus our most common styles of heat pumps. which, you know, is the air source heat pump, as we all know. But there are other types of heat pumps, like air to water or ground source heat pumps. We're not going to be getting into those today, but we're going to focus more on the air source heat pump. Hybrid and dual fuel systems are sometimes used interchangeably, I think, kind of what you alluded to already, Andy. But for the purpose of this presentation, I'm going to separate them. And I'm going to refer to as a hybrid system as an air source heat pump combined with a hydronic heating system, and then a dual fuel system as an air source heat pump combined with a gas furnace.
Nice.
So you'll see that when we get there. And then why would you want to even consider a dual fuel or hybrid system? I'm going to talk about adding an air source heat pump to an existing system or starting from scratch in a new build, for example. The options for dual fuel and hybrid systems are vast, right? And I'll cover several options, but I won't be able to cover all of them today, obviously. There's so many configurations that are possible out there. But I want you to know that you can reach out to me or Andy or Jason or anybody on the call today. If you have any questions afterwards, we can all point you in the right direction to get you the answers that you're looking for. And then actually, Stacy, if you want to put my contact info in the chat, that would be fantastic. And then what type of things do you have to keep in mind when deciding on dual fuel systems? Right. So, you know, it's not just as simple as, okay, this is what it is. Well, how do you know what to do? So I'm gonna get into the overall economics of the decision making at very high level. But I'm also going to come up with you know, what things you have to consider when it comes to replacement or new construction. I'm going to go over the online tools that are available to help you make your decision, and then I'm going to finally go over some of the with the additional time that we have at the end of this. You know, Andy, Jason, and I are going to be able to sort of take your questions. So, what is a standard forced air system? So, I'm going to start off by saying, please stay with me here because I know a lot of you already know what that is.
That's
right?
right.
But for the benefit of maybe 3 or 4 people on the call that don't know what it is, I'm going to sort of explain it just at a very high level, just so we have a basis of understanding for the rest of what I'm about to talk about. So what am I referencing here? A standard forced air system is what a very large percentage of Canadian homes currently have. Most Canadian homes, I would say, currently have a gas furnace for heating, natural gas, propane, or even oil, right? Paired with a vertical discharge condenser and coil, what we would most likely call a central air conditioning system. So, okay, so how does this work? In the heating season, the furnace is a box, right? You see it in the picture. So it's that box on the outside, or sorry, the furnace is the box on the inside of the house. Apologize. In heating season, the furnace blows fan over top of a heat exchanger that has a flame inside, and the distributes that air through the duct, right, towards the diffusers in the home, and then provides heat to the rooms. So in cooling season, what happens is the furnace, it has a secondary role. Well, part of it kind of does, right? So in cooling season, the blower fan still blows air through the ductwork, but instead of blowing over a hot heat exchanger, it blows over a coil or an A coil, some type of coil that has cooling inside. And what that does is it provides cool air to the home. What it's doing is it's actually absorbing the heat from the home and taking that through a refrigerant line outside and rejecting it through that box outside, which is called the condenser. So that's kind of how the standard system operates, right? So this is a continuous loop. As long as there's a call for cooling or heating, this is what happens. So now that we know what a standard system or how a standard system works at a very high level, well, what about an air source heat pump? How does it work? So an air source heat pump is a device that moves heat between the outside air and your home to cool or heat your space. The big difference between central air conditioning function and an air source heat pump is that it can do both cooling and heating. So the truth is, central air conditioner and an air source heat pump are largely the same. The equipment is very, very similar, and the way it works is very, very similar. They move heat from one location to another. So either from inside the house to outside or outside the home to inside. And with an air source heat pump, you can reverse the flow of refrigerant. So with an air conditioning unit, you have one direction of refrigerant flow. It's absorbing the heat inside, rejecting it outside. With an air source heat pump, you can reverse that refrigerant flow. You can absorb the heat from outside and bring it into the home.
I always like to remind folks that the only air, theoretically, that has no energy in it is air that is at absolute zero, which is 0 degrees Kelvin. That's the same temperature in space, minus what, 275? And even the best heat pumps that we have are only taking advantage of like 20% of the potential energy. Sort of cool. Anyways.
Right. Yeah, no, it's interesting. So, and you know, like you just said, when I say we take the heat from outside and we bring it into the home, well, a lot of questions come up, right? People go, well, it's cold outside. How can you bring the heat from outside into the home? And I'm not going to get into the science of it, Andy, but what I am going to say is that it does work. In fact, there is heat in the air outside, and you can bring it inside the home. It's not a very deep answer, but just know that it is very efficient at actually doing so, but gets less efficient as it becomes colder and colder outside. So the example in this picture here, that would be your modern outdoor heat pumps, one a vertical discharge heat pump and one is a horizontal discharge inverter style heat pump. And you know, obviously the next question is going to be, what is an inverter style heat pump? What's the difference, right? So you got a single stage, a dual stage, and you got an inverter. Oops, I think I skipped a slide there. So I got a delay here, Andy, 1 sec. Oh, there we go, okay. So inverter style heat pump, so what is it? So a standard heat pump, let's call it a single stage heat pump, right? Operates at a fixed speed. So it's either fully on or fully off. It's not necessarily matching the demands of the home. It's just providing the maximum amount of cooling you can at all times, or heating, for example, or for that matter. The inverter heat pump can adjust its speed to match the heating and cooling needs of the home, allowing a more precise temperature control and significantly greater energy efficiency. By not overly cooling or cycling, sorry, not over contributing the heating or cooling, and being able to, and cycling off and on too often. Essentially, an inverter heat pump is a more advanced version of a single stage heat pump with variable speed capabilities. Another advantage of not always running at full speed is the inverter style heat pump tend to be much, much quieter. So one thing that's important to note is that heat pumps gradually lose efficiency, kind of like what I was saying before, as it becomes colder outside. The lower the temperature, the more effort or energy it takes to extract the heat out of the outside air. Once it gets very cold outside, heat pumps also can't produce enough heat for the home. This varies from manufacturer to manufacturer in terms of what that temperature is, and it's based on the style of heat pump itself. So there are two specific classes of air source heat pumps that we generally refer to in Canada. And one is the standard heat pump, and the one is the cold climate heat pump. So to give you a high level understanding, some standard heat pumps can produce efficient heat down to, say, approximately -15 Celsius, whereas a cold climate heat pump may actually be able to create efficient heat all the way down to -30 degrees Celsius.
And generally, Steve, a cold climate or a low ambient heat pump is typically going to have a HSPF, and that's heating signal performance factor, for your zone, right? So zone 5 or 6 or whatever, that's around 8.6 to 9, I think is what sort of the low end is.
Right.
Good.
So now that we kind of have the basics of, what a standard system is, what a heat pumps, single stage, double stage, and inverter style heat pump, we'll get into sort of the nuts and bolts of this presentation, and that's dual fuel specifically, right? So let's take what we've learned about the heat pumps and incorporate the heat pump with a furnace now. Okay, so this is what we would consider a dual fuel system. One fuel being electricity, right? The inverter style or the heat pump itself, and the other fuel being, say, natural gas, propane, oil. It could be really any other fuel source, but another fuel source is incorporated with that as well. The example I'm using here in this picture is an inverter style heat pump with a natural gas furnace, and on top is your standard A coil that you would, very similar to what you would use in a standard air conditioning system. So why would we want to install a dual fuel system, right? This is the big question. So installing a dual fuel system, such as something like what's in the picture, a natural gas furnace with an inverter style heat pump, will give the homeowner the benefit of more efficient, greener, and quieter operating heating and cooling system, sorry. Then why not just go to a heat pump only, right? That's another question I get. Without the furnace, you just go to a heat pump. Well, the argument for using a dual fuel system in a cold climate is that in some applications, a heat pump will have difficulty or even be unable to keep up with the heating demand of the home when it gets very, very cold outside. If this occurs, the heat pump will need assistance from some sort of backup heat or auxiliary heat in the system. So if you were to install a straight heat pump, for example, that did not have a gas furnace, the supplemental heat in that type of application would end up usually being an electric resistance style element. Okay, think like toaster oven inside of the ductwork. In that scenario, the cost of operating the electric resistance backup heat in most cases is more costly than operating a gas-fired furnace for backup or auxiliary heat. So based on the utility prices and trying to operate your heating at the lowest cost, it may be less expensive to run a natural gas furnace in colder temperatures than a heat pump with a resistance element. Another benefit to operating an air source heat pump, including straight heat pump or dual fuel system, is that it should be important to all of us that the environmental impact of using a heat pump, right? With a heat pump being more efficient at heating and cooling at a home, it is less impactful on the environment than running a standard system. One of the limitations of this type of system is that in most cases, the heat pump and furnace cannot run at the same time. If the furnace is operating, the heat pump shuts down because you can't run heat over the coil while it's circulating the refrigerant. So if one is providing heat, the other is not. There are solutions to this, and I'm going to talk about them in a few of the following slides. Any questions so far that popped up?
I think we're doing pretty good. There was just some statements here. We'll actually have them move it over to the QA.
Okay.
So yeah.
Okay.
Well, it's good. It's good to take our time sometimes, because I think a lot of us will use terms or we'll talk about things, but we aren't really sure exactly how it links together. So that's good.
Yeah. Yeah. So we talked about a dual fuel system. Well, now I'm going to talk about a dual fuel hybrid system. And I don't think this is officially a term that you'd be able to research on Google. Kind of a term that I came up with on my own because I had to differentiate a dual fuel from a hybrid system.
That's right. Yeah, yeah.
But basically a another type of dual fuel system would be this, a hybrid system, right? Instead of using a traditional furnace, we use a hydronic air handler in this scenario. Okay, so what the hydronic air handler uses is a hot water coil inside of the air handler instead of a flame with a heat exchanger in that respect. And a gas boiler or a tankless water heater or combi boiler is used to heat that coil. All right. So when that's it, when that's the case, it's very, very similar to a dual fuel furnace example, except instead of having a standard furnace with the flame in it, we're using a hydronic air handler. The backup heat source for this would be that furnace, basically, would be that hydronic coil, that hydronic air handler. So we pair an air source heat pump on top of that unit. You can see it right here, right? And the outdoor unit, of course, right here. And that air source heat pump operates in most conditions for the heating and the cooling of the home, and only calls on the backup heat or the air handler when it is needed to keep up with the demand. So if it gets really, really cold outside traditionally. When this occurs, the heat pump shuts down, the air handler takes over, and a boiler or tankless water heater heats the water, circulates it with a pump to the hydronic air handler. Air flows over the coil in the air handler, which produces heat in the home. So instead of having flame in the air handler, we now have hot water. So a few benefits to this type of setup: efficiency, venting, safety. A system like this is often more efficient at producing and regulating heat to the home than a standard fully modulating furnace, even because of its ability to vary the water temperature and blowers. So because of that, we can actually get very, very, very efficient. Having control over those factors to match the load of the home prevents overcycling of the equipment. When installing a gas furnace, you need to vent the combustion gases. And I bet you a lot of the builders on here that, you know, as we're building more intensified construction of townhouses and stack downs and that's something we'll be able to relate with this. So you need to vent the combustion gases to the outside of the home, right? When you install any kind of gas appliance. And a lot of in most cases, I would say you also have to bring fresh air in from outside. Well, if you're doing townhouses, or stack towns, for example, because they are so tight together, the real estate is very, very minimal on the back of these homes to be able to vent everything. You got ERVs and dryers and water heaters and furnaces and everything, right? So another benefit to this type of scenario is it actually takes some venting out of the equation. So the hydronic air handler doesn't require venting with this type of application. The hydronic air handler is standalone, gets the heat from the water heater, so therefore we don't have to vent the air handler. We only have to vent the water heater. So that's another benefit. It gives a little bit more flexibility. And then it can also be a safer alternative to a standard furnace because there is no direct combustion within the airstream. So what it means is that if there was ever a leak in the heat exchanger, there would be less concern of any kind of carbon monoxide entering the home and creating an unsafe environment for the occupants. Here's another example of a hybrid system, and this is where I see a real big advantage. You know, you get a lot of home buyers or homeowners that have or want in-floor heating. They have radiators. There's a lot of different options out there. So in this example here, we are incorporating other styles of heating with the forced air system. By using a boiler, a combi boiler, and a hydronic air handler, you can not only heat the home with the heat pump, but you could also heat the home with in-floor heating or radiators and such. This also gives you the ability to cool the home if there is ductwork within the home. Obviously, you wouldn't be able to use this if there wasn't, and the cooling would have an issue. If there's ductwork in the home, it gives you the option to cool the home with that ductwork or with that heat pump as well.
This is something, Steve, we're seeing a lot more of, right? It's not only a hybrid between the fuel types, but also a hybrid between the way the energy is moved, one through air, one through water. You know, arguably, what is it, a 15 by 15 inch airflow duct can carry, you know, 12 to 16,000 BTUs, whereas a 1 inch water pipe can carry the same. One anecdotal takeaway from this is we're finding that in well-designed homes with, I'm going to say, rational enclosures or renovations where you've been able to impact and rationalize the enclosure, the low loads lend themselves to doing really cool stuff with systems like this. They can
Yeah.
be small, they can be precise, they can be right sized. You know, you're already going to need a little bit of airflow anyways, right, for ventilation. So maybe use some of the same size ventilation duct for some of that air distribution. Again, when you can control the load size. But yeah, lots of this is becoming popular.
And I, you know, like you said, Andy, precision really is the name of the game now with the lower loads.
Yeah.
And I do it a little bit further on in the presentation, but getting that air delivered to where it needs to be is really important. And I'm going to talk about that in a second. So when in this type of scenario, you can also see that we're also incorporating an indirect water heater. So in this case, you can actually heat the water inside this tank using the boiler or combi boiler. So you can now do your radiant floor, your radiant rads, your air handler, and your water heater, all with the the same equipment. So it just gives that flexibility to being able to do. And I like I said, I can't get to everything today. There's so many
That's
different.
right. Yeah, yeah. And I see some good discussions with Graham, McMillan, and others on the side, right? And again, Graham, the thing to understand too is depending on climate zone, depending on envelope design, you know, we have seen even the simple thing of windows, the wrong solar heating, the wrong orientation, just blowing cooling loads way past heating loads, actually, very differently than what you've pointed out there. So, but anyways, good discussion. So, and Robert Bean, very nice to have you on there today, sir. Have to get you on here. So Robert was just complimenting on referencing to Radiant, right? And of course, Robert, many of you would know Robert. Robert's the ASHRAE Distinguished Lecturer, and one of our good friends, and so helpful to the industry, describing why energy exchange by radiant means, as we get into some of these lower load homes, becomes a huge opportunity to control thermal comfort. We'll leave that for another webinar today with Robert, though.
If I wasn't nervous already, Andy, now we got Robert here. I'm really nervous.
I know, doing good, doing good.
So this is another term that I coined on my own, Andy. This is the reverse dual fuel hybrid system. So I'll explain so you have an understanding. So there's another alternative to the dual fuel system, the way I look at it, and the hybrid system together. So what I would call a reverse dual fuel system is a little bit different than the standard dual fuel system, in that in this scenario that you can see on the screen, the heat pipe. So what we have here is we have an actual full home heat pump air handler, right? That's what this is. This is not a traditional gas furnace. This is an air handler paired with an outdoor unit would provide heating for the whole home. But what I've done here is for the backup heat, instead of having an electric resistance style backup heat element inside the ductwork or the unit itself, I'm going to add a hydronic coil or heat exchanger on top of that unit in the supply air. And then if I ever need some additional help with heating the home, I can actually use a tankless water heater or combi boiler, supply that coil with hot water, and now I can use that as supplemental heat. Notice I said supplemental. That's very different than auxiliary or backup heat. Supplement, because what we talked about before when we're using a traditional style dual fuel system, one's operating and not the other traditionally. With this type of system, we can continue to operate the heat pump in heating season, but if it needs help, it can actually call on that coil to help, or that hot water to help it out. It will still run, but it will push over that coil and heat it up even further.
And this is, Steve, this system, and I've seen some comments here about systems like this. This is really a nice arrangement because the previous systems, traditional hybrid dual fuel, the air source heat pump actually shuts off so that the backup, if you will, can come fully on.
Right.
Whereas this system will allow that heat pump to continue to operate simultaneously, and you can take advantage of these heat pumps. Like, they will continue to run, even though they may not be meeting the load. They're still performing well over 1 to 1.2 COP, right? 1.5 plus, even 2, but they're continuing to run, and you're just dropping in a little bit of energy through that water coil.
That's right.
That's a
Exactly.
really nice, elegant way to do it. The other thing too that this keeps you from having to do is it means that there's no large draw on, let's say, an amperage electrical draw in some situations where we may have some restrictions to electricity or sizing of the panel in some residences.
Yeah, yeah. You're 100% correct there. And the other benefit to using the hydronic coil like this rather than electric resistant style is it's likely going to be more cost effective than that electric resistance. You know, it all depends on utility costs where you are, but that is a big factor as well. It may be more expensive to run that electric resistance than a little bit of natural gas and hot water through that coil.
The one thing I just do want to acknowledge is, you know, we know these systems work in the far north, climate zone 7B, climate zone 8, subarctic, the cold climate heat pumps. It's nice to have systems even like this that have the ability, it lets the heat pump run beyond its stated balance point, and the supplemental will be running simultaneously. But we've had some conditions last year where we saw minus 57, right? We saw minus 58 in some of those areas. And the heat pump did continue to run. But what happens with a lot of these even cold climates is when they turn off, even past their balance point, they do not turn back on until the ambient conditions come back up slightly. And so systems like this were sized to provide supplemental, but then also to jump in and take over when you got into those, you know, outside of design parameter conditions, which are rare, but it does help. So,
right. So another example of this would be maybe we have a basement apartment, Andy, and we want to use an air source heat pump. We don't want to have two separate systems. You know, in terms of outdoor units and full systems, what we can do here is very much the same as what we did in the last example, except for we have one outdoor heat pump, and that's servicing two air handlers, one on the second floor, one on the you know, say in the basement for that supplemental apartment. We use the tankless water heater or combi boiler to supply hot water as backup heat. And then we can even add a spot heating or cooling device, and let's just say a garage, if we wanted to. So this gives a little bit more flexibility with that type of setup as well. So we kind of talked about some of the different solutions, and then I think it's really important to think about what considerations do we need to think about when deciding on what type of solution is right for the homeowner, for yourselves, whoever you might be thinking of. And there are really, you know, three main factors is what I was thinking, and that is, you know, where is the system being installed? Right? What climate zone, as you were talking about earlier, Andy? Is it really, really cold up in you know, northern Ontario, or are we talking about southern Ontario? Very, very different requirements.
no, northern Alberta, Whitehorse. We might have some folks from Whitehorse
Oh,
on.
well, yeah.
And so there you go.
It's very cold, yes.
Yeah.
What are the economics of the project, right? So
Yeah.
what's the upfront costs versus what are the savings and efficiency? And then what will be the control strategy once we do make a decision on what product that we're using. So I'm going to go over two different scenarios in terms of like an existing replacement. So a re of a, you know, for the contractors on the call here that are doing replacements, these are the questions that you want to ask your customer, or that you want answered for making this, helping the customer make the decision. So I know this is a really busy slide. I know there are tons of points there, and to be honest with you, it was very intentional. There's a lot of factors to consider. So when we're talking about a replacement system, the first step is always asking the customer what they want, right? I'm sure the contractors on this call know that you got to find out what the customer's looking for before you make a decision. But they may not know about heat pumps or hydronic furnaces or single stage or modulating equipment, right? So this is all the stuff. And part of my role with my company is to educate the contractors and builders and so forth on the different technologies. And part of their role would be to educate their customers on what's available to them. The next question would be, what is, like, when you look around, what's installed now, right? Are there even ducts in the home to be able to do a dual fuel type system with an air handler? If not, then you're looking at a totally different solution. Do they even want cooling, right? Do they have a hydronic component in the home? Do they have in-floor heating now, or a boiler of some sort? And how do you incorporate that? What type of fuel is available to the home, right? So maybe it's propane, or maybe they have a gas fired furnace in their home, or an oil fired furnace in their home. Well, that's going to really affect what you want to use moving forward if they're looking to get more efficient, cheaper utilities, that sort of thing. So that's going to affect that for sure. Like, you may opt for a modulate. If you're on propane, you may want to go with a modulating system, for example. It would be much more efficient than a single stage type furnace. Does the homeowner want to operate solely or mostly on electricity most of the time? And this will help determine if you want to offer them a cold climate heat pump that operates more efficiently at low temperatures and will operate more often, or if you want to just offer a standard style heat pump that doesn't quite operate at cold temperatures and will call on that backup heat more often. And then it depends on where you live, right? You live in northern Alberta or Ontario, or the Yukon, or wherever it is. So is there enough load on the panel available? So this is especially in replacements. You walk into a home, let's say you walk in a 1940s bungalow or something. Maybe it's still got a 60 amp panel in there. Well, you're going to maybe have some trouble trying to fit in an air source heat pump to be able to supply. Even a 100 amp panel might not be enough, right? So a 4-ton heat pump could use as much as 50 amps in some cases, depending on what you're using. So, and then, this also changes the capital cost of the system if you have to start upgrading services and panels and all that kind of stuff.
Yeah. I'll give you a little bit of an insight color commentary. We're finding that on the existing side of homes, on the renovation side, that often if there is the ability to do some advanced air sealing on a typical existing home of, mid-range sign, typical home, the impact on the heating load is substantial enough that you could get the load down low enough to do a cold climate system that can actually be cost competitive with a gas dual fuel. But you do have to impact the load of the home. So there is sort of a sweet solution between air tightness and heat pumps, heat pumps, that we can do this. The other thing too is I noticed the duct work, is it sufficient? This is something that we would encourage. We've done some studies with Natural Resources Canada, CASE, Canadian Association of Consulting Energy Advisors has done a national study with Enercan to actually look at the existing ductwork in some homes. And reality is that much of it is sufficiently sized enough that we can move to heat pumps and some of the increased airflows. But again, we need to do more than just look at the size. We also need to look at the available static pressure. And not only is the ductwork size enough, but is it sealed enough to maintain the static pressure? So for those of you that do this kind of work and install, there are tools that are very simple for that. The TrueFlow from Energy Conservatory, you can get it on TrueTech tools, very inexpensive, takes 15 minutes to run, and you can absolutely right size and ensure you have proper airflow for the systems. Anyways, I'll shut up. Keep going, Steve.
Oh, thank you. Can I do a time check though? How much more time do we have here?
Yeah, we got, I would say another 5-10 minutes. Is that okay?
Better whip through it. I got 8 more slides.
Okay, I'll be quiet.
All right. So we also have to look at the ductwork, as you said, right? We have to make sure that it's able to accommodate the air. And we also have to make sure that the leaking is not too much, because if we got a modulating or let's say a heat pump that's modulating and goes to a low speed, if we're losing 30% of that air through the ductwork and it's not getting to the place it needs to, could run into challenges in that respect as well. How long are the homeowners planning on staying, right? It's an economical decision a lot of the time. A lot of times, if they're going to be moving within the next 5 years, maybe they're going to want to opt for maybe a cheaper solution. If they don't care and they just want to do what's right for the world and put in an efficient system that's better for the environment, fantastic. But that is a deciding factor for sure. And then finally, is the homeowner concerned about installing a more environmentally friendly product? And if the budget's there and they just want to put in the best thing for our world, then heat pump's probably the right solution for them. So in new construction, so some of the other stuff applies that we already talked about, but there's some other additional stuff when we're talking about new construction. So what are the demographics of your homeowners, right? Can you pass that, are you going to be able to pass that cost on to your homeowner? Do they care about the increased cost of the equipment if it does cost more? That's obviously an important thing that you have to consider. As a builder, do you want the service? Do you even want to service the property with natural gas, right? Do you want to have any kind of other fuel at all, or just electricity? So, and I say this, and I apologize, the Enbridge folks, but there's costs associated with that, right? If you're barely using your natural gas for the heating section in a stacked town, for example, you're barely ever calling on that backup heat. Maybe it's a cheaper alternative to actually just go all electric in those.
And I think we have to, that's true. The other side of it is domestic hot water, right? Like it still is, domestic hot water is a big load. So, and many neighborhoods want the resiliency, they would say, of gas, things like that. And I don't want to get into the esoteric arguments about energy, but there's a lot of factors that need to be considered so that we can still maintain some resiliency. Yeah. Anyways, keep going, Steve. So.
And then do we have to meet certain energy requirements, right? Net zero or Energy Star. And, the guys like Andy and Jason, the building knowledge team, will be able to help you with selecting the right equipment based on what label you may be building to. If you are adding electrical load to the home and everything's going sort of electric primarily, do you need to upgrade this service to the development, even with, bigger transformers or 200 amp panels or 400 amp panel, whatever it might be? That's a consideration on the capital cost. What type of heat pump do you want? Dual fuel or standard, so cold climate or not? Those type of questions. Do you have to change the architecture of the home? Maybe your original solution was to put mini splits in the house, have zoning in each room. If you want to go to a dual fuel system, you need to put ductwork and that sort of thing. So you may have to change the architecture. And then finally, what is the return on the investment, right? Can you pass this increased cost, if that is the case, which in most times it is, onto the buyer, right? Can you train your sales team to sell the increased efficiency to the homeowners? And how does the affect the affordability in general to the homeowner? Maybe you just want to make the world a better place, and I applaud you for that. Economics. So here's usually what ends up being the deciding factor for most people, right? So how much does it cost? How much is it going to save me? I can't answer that for you because I don't know where you're all from, right? Every jurisdiction has different prices for utilities and so on and so forth. But there are, and just know there are a lot of variables, right? The Canadian dollar, the cost of the equipment is different from place to place, the cost of utilities, taxes, rebates available, all sorts of things to consider there, and then geographical location. Right? What I can say is that upgrading to an air source heat pump from a single stage AC will cost you more upfront without rebates, for example. But cheaper to operate in the long run. That's traditionally what we see. And it will eventually pay for itself with the current standards that we have or the current utility costs that we have right now. The return on your investment will change depending on where you are and what the cost of the equipment, installation, utilities is, as well as rebates available. And there are rebates available, such as, there's an oil to heat pump rebate for households. It's a national program. If you wanted to switch from oil heating to heat pumps, for example. Control strategy. So this is, I'm going to try to rush through this quickly. I know we're almost out of time here, Andy, but basically we want to determine when that switchover point is, right? So first of all, in a paired system, let's just say a Lennox furnace and a Lennox heat pump, there may be like a proprietary thermostat that comes with that unit that will be able to determine what the proper switchover point is, or switchover temperature from heat pump to furnace. That's called the balance point, by the way. And there's really there's two kind of balance points that we traditionally use, and that would be an efficiency or an economical balance point. The efficiency, I'm going to get to it on the next slide, which has a couple of graphs, but the economical balance point, you will switch it over when it's cheaper to run one fuel the other, whereas the efficiency balance point will run the heat pump as long as it's able to provide enough heat for the house, and then switch over to the furnace to provide heat. Does the equipment itself have the ability to switch over? So some equipment, air handlers or so on and so forth, actually have that ability within their control board to do it, or do you need a smart thermostat to do that? And then if you're using the economical balance point, is it going to be important? It's going to be important to stay aware of what the cost of gas is versus the cost of electricity, and what that balance point is. And when I get to the slide for now, so this is what your economic and efficiency balance point. I'm not going to go through it in detail, but what you can see here is in the economic balance point, we're actually switching over here. We're switching over, even though the heat pump can still provide enough heat for the home up here, we're going to switch over at at a warmer outdoor temperature, because at that point it's cheaper to run the natural gas furnace than it is to run the heat pump. As I said, the efficiency balance point switches over when the heat pump can no longer keep up with the demand. So I'm very cool with this. And online resources. So there's one, I'm going to point you to only one that really has most of the answers that you're going to need. So that's the NRCan LEAP Air Source Heat Pump Sizing and Selection app. It's fantastic. It walks you through a 13-step process, from anything from ductwork to return strategy to the style of heat pump that you want, dual fuel, high wall. There's all sorts of information on that.
You're going to see Jason use that in his case study, actually. So
yeah,
it's free, folks. It's
really
free.
great.
I want to make note that there's about 7 questions in the Q&A that we're all going to answer around cutoff, how to decide it, how to calculate it, what tools to use. So we're going to answer all those 6 to 7 questions in one fell swoop.
The other cool thing this does is you can actually decide which equipment you're considering, and it will give you the breakdown of the cost of operation. So you can see that.
Yeah. The other thing too that is really nice is the tool actually allows you to look at how different heat pumps are. They're not all created equal. So it can single out heat pumps that may have high advertised rates, but have very poor, I'm going to say they don't have a nice gradual curve. They sort of fall off the cliff as soon as you get, into cold temperatures. And what we want is we want heat pumps that continue to have a very small gradual decrease over time, not ones that plummet off the cliff at a certain temperature. So, and you can only see that by using tools that will give you the variety of ratings at multiple temperatures. So,
thanks for saying that, Andy, because that's very, very true. Not all heat pumps are created equal. So this is the second to last slide. It's common practice in the past just to throw a big furnace in a house, right? And forget about it. A lot of contractors will still do that. They'll see an 80,000 BTU furnace in a small 3-bedroom bungalow, and they'll just throw another 80,000 BTU furnace in there. It's very normal, but this plays a big role in the overall comfort of your home. You get a lot of cycling, that sort of thing, if it's oversized. This is just kind of a general step-by-step guide on how to select the right equipment. So work with a contractor, certified HVAC designer, or both, and have a heating and cooling calculation done on the home. So size the equipment based on the outcome of that calculation, not based on what's already installed there. Determine the type of system the customer or builder wants to install. And then the third step would be, and this is usually done by the HVAC designer, but refer to the manufacturer's data sheet to determine capabilities of each equipment. Like you said, Andy, all equipment is different where they lose the ability to operate, efficiently. So, and then, you can also determine, how the product performs using that NRCan website. Like I said, how efficient it works as well. So. And then the last one, just kind of go over a little bit of a recap, kind of what we learned today. I'm hoping that you learned some stuff, but we learned about what a heat pump is and what a standard system is, right? We learned what a dual fuel system is. We learned, my version of a hybrid system or dual fuel hybrid system, various types of systems. We talked about, what considerations must be made before selecting your solutions. We talked about the control strategy, and we talked about sort of the steps in selecting the right equipment for your application. So I just want to say thank you very much for allowing me to present that to you. If you have any questions, I know anybody on this call today would be happy to help you with selecting the right equipment, or if you have any questions, feel free to reach out.
Excellent. Thank you, Steve.
Thank you.
Yep, you can go ahead and unshare your slides. Jason, we're going to bring you on. And Jason, I think we are running behind, and that is my fault, not Steve's fault.
Sorry, guys.
Jason, if you can move us through your case study fairly quickly. This is a case study. Jason's done hundreds of these designs, but we thought it'd be nice to showcase an example of a simple hybrid type system that is very doable for entry-level projects. Oh, and by the way, over in the chat, please note that is a link to the air source heat pump sizing tool that Steve referenced, and that you'll also see that Jason and our mechanical design team use almost every day on projects now. So,
thanks, Andy.
Hey, you're welcome.
All right, so I will try and be quick, being mindful of the time, because we do want to answer a few questions at the end. Okay, so can you all see that screen?
We can. Looks
okay.
Good.
All right, so this is a case study courtesy of Bickle Built Homes. They're a client of ours. This is a very recent build that they've done in St. Mary's, Ontario. So this is a 1,400 square foot bungalow, 2-bedroom, 2-bathroom, fairly typical of what they build nowadays. And this is a net zero ready home. So I chose Bickle because they're one of the builders that we work with that does use a hybrid approach. They're using a hydronic air handler along with a cold climate air source heat pump to meet the heating and cooling loads of their homes. And ever since they've gone to net zero ready, they have seen that the average heating and cooling loads of their homes have gone down compared to how they were building 5-10 years ago. So we'll get to those numbers for this property in a moment. But I did just want to show just a quick overview of what that duct layout looks like. So it is still using sheet metal, still a fairly average layout for a house of this style. We've got our mechanical room here near the front of the house, and then our ductwork just goes across the joist, and our supply and returns travel as shown. Then our main floor looks like this. So again, not too much of a departure from what most builders are used to. But where the change comes in is going to be in the sizing of the equipment. And as Steve alluded to, it might be a lot smaller than what they're used to for this kind of product. So this isn't the exact equipment that's been installed in this house, but it is fairly close to what's being shown here. So this is a hydronic air handler with a tankless boiler. So the boiler will be doing your space heating and domestic hot water production, as well as it'll be paired with a cold climate heat pump and an ERV. for ventilation. Just a simplified connection in this house.
Jason, I'm just going to make a comment. I think it's worthwhile. Brett's
Yes, sir.
online. One of the things about the homes that Bickle builds is that they are built incredibly well. They are airtight. They have very good effective R values and good windows. So very rational envelope. And what happens in those homes is this is effectively a low load home. We're talking about a home that's down into that, close to that 10 BTU plus a little bit minus a little bit per square foot. That means that Bickle homes really cannot use a traditional forced air system, even fully variable, because the system would likely short cycle because of sizing. And what this system allows this home to do is to ramp down to very low BTUs, just a little bit at a time, so that you get consistent comfort and energy delivery through the home, regardless of part load scenarios. And I think that's really important point to make.
Correct. And to your note about the envelope, I just wanted to briefly show what that looks like real quick. So, again, this is a net zero ready envelope, net zero ready house. So we have R60 in the attic. The main floor walls are an R22 with an R6 zip panel. Basement's going to be an R20 with an R6 layer of continuous insulation on the concrete, and then R10 underneath the slab, underneath the entire slab. Windows are going to be a U value of 1.2 or greater. I believe they're also triple pane with low solar heat gain. And it's not shown on here, but the air tightness target that I've used for calculation purposes is 1.5 air changes. And Brett will be happy for me to mention that they regularly test below 1 air change. So even with all this taken into account, their homes actually do perform a little better than we would assume. Okay, so just a quick rundown of what those loads look like. So here, taking our envelope, conductive loads and ventilation loads into account, altogether we're coming out to about 23,000 BTUs per hour. Again, at an air tightness of 1.5, so in practice it will be lower than that. And with a total cooling load in the summer of about the same, about 22,500 BTUs. So this is, again, in St. Mary's with an outdoor winter design temperature of 0 Fahrenheit or -18 Celsius, which we've seen in that area within the last 2 weeks. So it's absolutely not an extreme for that area. It is something that's expected. Moving on, this pie graph just kind of shows the breakdown of our loads here. So even with an air change of 1.5, we can see on the heating side, infiltration actually takes up about 20% of the load. Even though infiltration is about 4,800 BTUs on less tight envelopes, you might see that in the 10 to 15,000 BTU range, which would account for, if that were to scale up, that being 20% of the total heating load, that would account for quite a bit of heat loss. So all that to say, just tightening up the envelope might improve the performance well enough to, let's say, go down a size in equipment, or at least reevaluate the equipment size that would be there already. Next slide. So just a little bit of a closer look at the equipment that was chosen for this home. So again, we have our hydronic air handler, iFlow branded, and that'll be paired with a Navian tankless boiler. And again, that'll be doing heating and domestic hot water. And then the heat pump here chosen is a Comfort Air 24,000 BTU cold climate heat pump. So in the calculations the numbers that I saw by using the Enercan heat pump sizing tool, putting all this information in there and graphing that against the heat loss of the home tells me that this combination of equipment, or this heat pump at least, will provide about 90% of the heating required for the year. And then the remainder will be picked up by the hydronic air handler. So the hydronic air handler should really only kick in when the outdoor temperature gets down to near that design temperature of -18, or on some rare days even below that. So this graph here just shows a quick comparison of.
And Jason, this is
Yes, sir.
from the Enercan air source
Yes.
heat pump tool that we've
This.
provided a link to and that
Yep.
Steve was talking about. Yeah.
So this is from. So the
So
tool
this
exists.
tool, yeah,
Yeah.
so this tool, just to be clear, can be done very simply by the contractor, where you put in the numbers very simply, but it can give you all sorts of things from greenhouse gas emission comparisons to energy efficiency to balance point, thermal or otherwise. So it's a fairly comprehensive tool, but we have a whole nother video with Jason on our website with that already. You can go watch. So.
So this bar graph here just shows a comparison of two heat pumps and their CO2 emissions. So heat pump number 1 is kind of just a base 14 SEER single stage 2-ton heat pump, kind of the most common bare bones unit you could find. And again, we just selected it for comparison's sake. Heat pump 2 is the proposed equipment that, or not proposed, it's the equipment that did go into this house. So the tool itself does provide flexibility to compare up to 4 heat pumps together. So you could see, they all may say that they are of a certain size, like they all might say they're 2 tons, but their individual operating characteristics will have an effect on operating cost and greenhouse gas emissions and just overall energy usage. So this is a good way to compare those things. But again, for simplicity's sake, for today, we just compared a base unit with what went into that house. So heat pump number 1 here, heat pump number 2, we can see it uses or it emits a little less greenhouse gases. And then this bar on the right is just backup only. So we've defined our backup source as natural gas. So if we were to heat the house strictly with a natural gas furnace, this is how much greenhouse gas emissions would result. Again, it is still a broad estimate, and then using a simple heat pump, it would go down a little bit, but not too much. And then using a cold climate heat pump, it would go down a bit more. And again, as Steve said earlier, not all cold climate heat pumps are created equal. So even if we had 3 or 4 cold climate heat pumps, we could compare them all and they would have different emissions.
Yeah, and we've seen some heat pumps will lower that number quite substantially. But like you said, that's the use of this tool allows you to validate performance.
Mm-hmm.
Good.
This next slide, and again, this is very contingent on utility fees for your area. But this next slide actually will roughly calculate the heating season cost for each system. So again, we have heat pump number 1, heat pump number 2, and then backup only. So in this case, we calculated that utilities in St. Mary's, they're going to be including taxes and carbon taxes. I hate to say that, but including taxes and not including fixed costs, we calculated it was going to cost about 45 cents per cubic meter, which translates into the cost that you're seeing here. We're seeing $636 for using a bargain basement heat pump, $592, a little less for using the cold climate, and then $648 if you were to just use gas alone. Now, this graph may not look that impressive, and I'm going to admit it doesn't, but this mainly has to do with the cost of gas versus the cost of electricity in a lot of areas. Andy, you want to jump in on that?
Nope, that's fine.
Okay.
I've just seen the commission. So again, folks, this is 1 out of 100,000 different pairings. Todd made the comment there. Thanks for that, Todd, that would have thought the greenhouse gas emissions would have been lower. But keep in mind, this is one combination. And keep in mind too, that when you look at a different size house with a different size load and a different volume and a different area, different climate zone, these extremes will change. They'll go up or down in the home. So, yeah.
And then lastly, this just shows our energy consumption. So again, heat pump number 1, heat pump number 2, cold climate, and then natural gas altogether. So if energy consumption is an important metric for you as a builder, then even just comparing cold climate heat pumps against each other again will give you an idea of how much energy they will use compared to gas.
And I can add to that, Jason, when
Sure.
when you're on the NRCan website, if you put your utility costs in where you live, it will actually tell you what that dollar.
That's right.
Good.
Yeah. And keep in mind, I just want to go back to make this point again, is, you know, try the tool out, put in your own scenarios. You don't need a whole calculation. It's very simple. But if you were to take something like, you know, Steve mentioned, I'll take a brand, Fujitsu. Fujitsu's got a very nice cold climate heat pump. If you were to apply some of those units, specific units, not all, but specific units, right size, right selected to the scenario, your HP2 plus backup would drop in many cases precipitously. So again, that's why we have to be careful of heat pump selection. Now, again, that unit is more costly, but again, what is the homeowner's needs? What are they looking for? All that kind of a thing. So good.
And that's the end of my slideshow.
Thank you, Jason. Very good. So yeah, we do have some questions here. I'm going to take a look at them. We're not going to get through all of them, but we've had some very good ones. I've seen some costs here. Folks are giving some various costs of systems, things like that. That's great. Feel free to share. I'm just going to simply say our observation in doing designs and analysis and working with builders across almost every single province and a couple territories and through the US is costs are all over the map. We're actually seeing entry-level 3-season heat pumps, maybe borderline cold climate, come in some cases almost at the same price as a 14.5 SEER air conditioner. And in other cases, we're seeing quite a cost differential. But again, this tool allows you to evaluate the benefits of possibly moving to a really good heat pump versus just a 3-season and the benefits of doing that. So let me take a couple questions here. Maybe we've answered some of these. And I will not get through them all. Question was Ontario Building Code for hybrid systems. So I'll quick answer some of these if I can. Jose, this is you can use this for you can actually use hybrid systems in many of the packages. However, if it's a hybrid system and the load is primarily satisfied through electrical means, you do have to go to the electrical portion of the SB12. If it is a combo type system, which Jason also spoke about, you then have to use package A4 as a reference. We'll go to the next one. In hybrid system application, do you keep the heat pump running while using the heat pump for heating? Yes. I think we showed an example of that in a well-designed system, sort of an optimized system, is you want that good heat pump to be able to continue to run as opposed to switching all off, all on for a gas backup or a backup source. Let it continue to run and then supplement in just a little bit of energy. Kenneth Klassen, what is the approximate additional capital cost to install a dual fuel system, cold climate, integrated with high efficiency gas furnace in an average size new home? I think there's been all sorts of costs on that. Steve, do you want to give a sense? Again, a cold climate with a dual fuel furnace versus an air conditioner. Do you want to give a sense percentage wise or comfortable with that?
I would say you're probably, it could be anywhere between 20 and 50% more expensive doing that than your standard air conditioning.
So it could be, you know, another 4 to 6 to 10. But again, I want to back up just a little bit. We have seen areas where, for instance, because of the cooling load and the size of the humidity, lakeside in many of the Great Lakes areas here around Ontario, even some coastal areas, believe it or not, across Canada, the humidity load is so high that it actually benefits us if we go to a cold climate unit, because a lot of those cold climate units on the cooling side have really good latent load capacity. They have dehumidification modes. And so again, I'm really cautious to ever make decisions just based on cost. Back to Steve's point, you need to understand the weather outside, the location it's designed, and also the expectations of the client. So again, we need to go a little deeper on some of that. What method would you recommend to determine the temperature set point at which it becomes economical? Jason, I think you're satisfied with the tool.
The Enercan tool will absolutely do that. Again, it comes down to just a comparison of your utility costs and the efficiency of the unit that you are using. So the Enercan tool is just a great way to kind of collate all that and kind of make it easier to figure that out rather than do a whole bunch of long calculations by hand.
Good. Todd, you had a question. Switchover temps have a strong influence. Could you comment on best practice? You get F280 heat loss, dictates the supply furnace sizing, but not the heat pump size or switchover. Absolutely. So number one, a good thing to have actually a good F280. That's the cornerstone of everything. However, you are right. It does not dictate switchover or a type of thing. So that's why you would want to use like correct equipment sizing. Couple things, HRAI Digest. I think Tech has got some stuff out west. In the absence of that, we often use Manual S, right, Jason? ACA Manual S for sizing is actually more detailed in some cases. As far as the switchover temp, Todd, yes, use a tool like the one you just saw. That's what it's there for. That will definitely start to give you a more appropriate switchover temps. What type of controllers? Steve, you can comment on that one. I know that's a nuanced conversation. Controls for these hybrid dual fuel systems.
Yeah, so you know, a lot of the smart thermostats out there, the Ecobees and Nests, and they'll give you that ability to switch over the equipment from heat pump to gas furnace, for example. I know the iFlow that Jason was talking about, that has the ability to switch over built right into the control board, switch over without the use of a smart thermostat. So that depends on the equipment, but there's lots of control and paired systems. You know, like I referenced the Lennox system or you know, Mitsubishi system for whatever. You know, a lot of them will have their own thermostat that offers.
Yeah. We are a little cautious. I know Jason and Steve and I have seen scenarios with some of the, I'm going to say, higher end cold climate units. You do want to be sensitive to using, you know, non-communicating versus communicating thermostats. A lot of the manufacturers of the third-party non-communicating do have the ability to run the units, but the actual algorithms are not in there to allow it to meet edge case scenarios. So we have seen, you know, during cold weather snaps or extreme humidity, that if the actual manufacturer's communicating thermostat is not part of the solution, you may have a little bit of an issue there. It's not a warranty thing in most cases. It's just that it doesn't have the algorithm that allows that smart equipment to optimize what you've got. So sort of like putting an old pair of 1980 tires on a brand new, I don't know, electric vehicle. Anyways. We've got a question about just broadly, Steve, do you think we're going to see the day where air conditioning units are simply going to be heat pumps?
I hope so. You know, I wish my neighbor had a heat pump much quieter. Every time his kicks on, it pretty much wakes me up. It's that loud. So, you know, much more efficient. You know, they're more compact, right? They're side discharge as opposed to top discharge. To get that efficiency out of them, you don't need a massive heat exchanger like you do in the you know, the box style ones. So, yeah, I think it'll happen eventually.
I think with the weather they've been having in Florida with 6 inches of snow in Pensacola and Texas, I think everyone's ready to flip over their only cool units, eh?
Yeah, true enough. True enough.
Let me just cherry pick a couple of these for the case study. Real quick, Rudy asks, what was sort of the square footage on that house, Jason?
1,400.
1,400. So there you go. You do the quick math, and that home starts to fall into
1,400. No walkout, single story.
Yeah.
Just to answer his question.
Service life, some questions, Steve. I don't know if you want to comment on that. Kenneth asked, what's anticipated service life of cold climate compared to a central air conditioner? Now Kenneth gets really specific here, so that's good though. Scenario 1, cold climate with electric resistance, heating primary, space for spacing. Scenario 2, cold climate with a hybrid, right, with a gas furnace. Is there any life expectancy differences when you've got sort of a combustion based versus all electric?
Yeah, I think there's a little more maintenance involved, right? If you, the more equipment that you have, the combustion type appliances that you have, there's maintenance involved. Um, the life expectancy, though, I wouldn't expect to be any less. You know, heat pumps in general have, you know, 10, 12-year warranties on them. Very similar, if not in some cases more than what a standard, you know, furnace would have on it. Life expectancy, I wouldn't say is any worse. If you were to do a cold climate heat pump with electric resistance, you probably have less things that could possibly fail. So you're probably covered a little better in that respect. But you know, it's all what you decide you want.
Yeah. Zoran, good to see you, Zoran. Zoran asked a good question, right? So production builders building, you know, let's say arguably affordably, price points of concern, you know, we've got affordability issues. Let's say if we get into, you know, products that are single detached or, you know, even multifamily, what's the sort of that first step for these builders to get into it? I have my opinion, but
it, like I talked about in the presentation, right? Depending on the what they're building to, what level of efficiency they're building to, will also dictate, you know, what they require to do. And I think in our challenging times that we're having right now, a lot of this is about, you know, a lot of decisions are being made about cost savings, that sort of thing. The first step I would say would be to reach out to, you know, a building knowledge or even us, to look at different options, to evaluate what the cost difference would be, what the benefit would be to the homeowner, and then move on from there and make your decision based on the information you get back.
We can often, to Zoran's point, it is good to go a little bit beyond just the mechanical itself. You know, take a look at the envelope, do some analysis, look at loads. And there, with some slight tweaking, without any cost, the tweaking of the envelope oftentimes can result in some right sizing opportunities on the mechanicals, which will enable you then for a no cost change to move from an AC unit, a standard AC 14.5, to a entry level heat pump that could complement something like a combo, right? Or something like that, or a good traditional system. So it's glad to help with that. But yes, there are some simple ways to get into that. And we are seeing a lot of that these days as we move forward. Quick question, F280 training resources. Jason, you want to take that on?
Yeah, HRAI in Ontario at least, or at least Eastern Canada, HRAI is pretty much the only source I can think of right now that provides F280 based heat loss and heat gain training. They also have, I mean, they publish their own manual, so if you get the course, you'll get the manual as well, or you can buy the manual separately for self-study. On the West Coast, I know Andy mentioned earlier, there's TECA, and they also have F280 based training and resources and reading material.
Good. Yeah, but lots of good. Casey's also doing something with HRI as well too, on some of the F280 training as well. So,
and of course, if they want the standard itself, they could always get that from CSA.
Yeah. David asked a question. We're going to do this last one because we got to wrap her up. David says, what is the premium? Is there a specific set of criteria that makes a hybrid concept a bargain, or is it a premium in all scenarios?
I don't know. Okay, I'm not on mute. You know, rebates are going to play a huge role in that. You know, with some of the rebates that have been thrown around over the last couple of years, it makes it, I would say, equal or even less than possibly just replacing a standard system. So,
yeah,
I think 7% of homes now have a heat pump installed in them. So,
isn't that something, eh? 7%. So again, good question. I'm going to say from our experience, it's not necessarily always a premium. And in some cases, yes, there is the ability to do it for a cost neutral or a cost less. but again, you need to approach from a whole house scenario. I'm going to wrap this up, and we're going to thank you folks for attending today. If you have any questions, feel free to reach out to Steve or Jason or myself on this. Let me just get my screen back up here, because we do have just a couple final things to talk about. We are about to, bear with us, in the next 2 weeks, we're going to release probably the next 4 to 6 sessions for our webinar series. We've got some topics nailed down and some excellent guests that'll be joining us as well. Make sure that you are on our Building Knowledge Canada, our Building Knowledge Builders Digest. There's a bunch of other additional building science highlights that are in there, and we bring in different topics that impact the industry and sort of some cool achievements by builders across Canada. So thank you again for attending today. Special thanks to Enbridge, the team there, for supporting us in these efforts as well, especially on the one today. And to all the rest of you that joined us today, have an excellent Thursday. And look out for your notice in the next week or two about our next scheduled sessions. So thank you very much. Thanks, Brandon, Jason, Steve, and Stacy and the team.
Thank you, everyone.
Thank you, everyone.
Thanks, everyone.
Take care.
Take care.
Good Thursday.